So these two sections are going to be about ratios and proportions, and then how they work with similar figures. So I'm going to go over some of the examples from this section and some of the things that you should have found out from your investigation. So first, I'm going to talk about ratios. So ratios, like this particular problem here, where it asks you to find the ratio of girls soccer players per school. What you need to see is that you have girls soccer players first per school. So what that tells you is that the number of soccer players goes on top, and that's this number right here. And per school, that's this number right here. Now, when we want to find soccer players per school, we want that to be one school, not 8,218. So we're going to go ahead and divide those two numbers. To get about 32.9 girls soccer players per school, because they asked us to round to the nearest tenth. So basically you want to see, when they ask you to find the ratio, whatever comes first goes on top, whatever comes second goes on bottom, and then you can either simplify that and keep it as a ratio, or like in this particular problem, go ahead and divide those and get a number to the nearest tenth. Now, as I talked about in the video, sometimes you're going to get extended ratios where you have more than two, so we don't just have a fraction. In this particular problem, we have a triangle where the ratios are 2, 2, and 3. Now, that's not the actual sides of the triangle. So what that means is I can get the sides by taking 2 times some number for these two sides, and 3 times some number, that same number, for the third side. That means a ratio of 2 to 2 to 3. And then the second thing they tell me in this problem is that the perimeter is 392 inches. Well, perimeter is just adding up all the sides. So I can make the equation by adding up all the sides and setting that equal to 392. So then that tells me 7x is 392. So 392 divided by 7 is 56. So that's just x. We want the longest side of the triangle, which is the 3x. So that's going to be 168. So that's how you can use ratios in order to solve for missing sides. And then, of course, I talked about using proportions with equal ratios, and using that also to solve for missing values. So you've probably solved proportions like this before, but like I was saying in the other video, we're going to multiply those two. We're going to multiply these two, because these are supposed to be equal ratios. So in order for that to happen, the cross products have to be equal. And so I want to solve for x so that those cross products are equal. So I solve that equation for x. To get that x is 1.5. That's all you have to do to solve a proportion. So when the directions say solve a proportion, they really mean find the value for x that makes those two equal ratios. Okay, and when you have more than just x, and we still are going to multiply, but in this time I have to make sure I distribute. When I multiply 5 times x plus 3, I have to multiply all the way through. And then we'll multiply these guys. So I get 5x plus 15 equals 8x. 3x equals 15, so x equals 3. And again, once I get what x is, I have solved the proportion. I don't have to plug that back in and make those equal ratios unless I want to check to make sure that it works. When you are setting up a word problem, as I went over in the video, there are a lot of different ways to make your proportions so that they're equivalent or proportions. But what you want to do is you want to make sure that you have the same things in the same areas. So in this particular problem, we have a twin jet airplane that has a length and also a wingspan. And then we have a model which also has a length, which we have to find, and a wingspan. So what I can do is I can set this up so I have length in one spot, wingspan in another. And then over here, I'm going to have the airplane, and down here I'm going to have the model. So if I set that up that way, then I have a place to put everything, because right here is going to be the airplane's length, which is 78 meters. Right here is going to be the airplane's wingspan, 90 meters. Down here is going to be the toy model's length, and that's what I want to find. And then over here is going to be the model's wingspan, which is 36 centimeters. Now, you'll notice that those are different units. So it's okay to keep them as different units because I need my cross products to be equal. As long as this cross product, which is meters times centimeters, is going to be equal to this cross product, which is also going to be meters times centimeters, then you're good. We don't have to change those units. So when I cross multiply, I get 90x equals 78 times 36. I also know then that x is going to be in centimeters. And I get 31.2 when I solve that. And that is the length of the model. You could also have set this up where these were in different spots. The only way that this proportion would not work if you would get the wrong cross products is if we turned one of those upside down. So as long as you're labeling all these categories with the 4 different categories that you have, that won't happen. You'll put everything in the right place. Because you could have had 78 over 90 equals x over 36, and you could have had any of those proportions, those ratios turned upside down, both of them turned upside down, and it would be okay. But if we turn one of these upside down and not the other, that's going to give us a different cross product and we'll get the wrong answer. So be sure you pay attention to what kinds of proportions are equivalent to make sure that even if your proportion looks a little different than somebody else's, that they give you the same cross product. All right, then I went over the similarity of polygons. And you can tell if polygons are similar by all their angles are corresponding angles are congruent, and in this particular case that's true. The two 30-degree angles are congruent, the two 90-degree angles are congruent, and so we know that the third pair of angles has to be congruent because they add up to 180. So it checks off that all the corresponding angles are congruent. And then we need to look at the sides. Now, how do we know what the corresponding sides are to make the correct ratios? Because the two triangles are not facing the same direction. What you want to do is you want to use the angles. So across from the 30 is the 4.5 and the 6. That's going to be one ratio. Across from the 90 is the 9 and the 12, so that's going to be another ratio. Make sure you're putting the same triangle on top and on bottom. So I started with ABC for the green ratio. I had to start with ABC on the top for the blue ratio also. And then my last ratio is going to be across from the 60-degree angle. And so that's going to be 6 squared to 3 over 4.5. Now, how can we tell if those fractions are all equal? Well, there's a couple ways you can do that. You can put those in your calculator, and you can just divide them and get a decimal answer. Oops, I forgot. So if I do that, I'm going to do 6 divided by 4.5. I'm going to do 12 divided by 9 and 6 square root 3. Oops. Square root 3 divided by, and I need to put this in parentheses so that it's dividing by both of these, 4.5 square root 3. And then I can see each time I got the same decimal. So that shows me their equivalent fractions. The other thing that I can do is I can divide as a fraction in my calculator. I can put each of these as the fraction that they are. And that's going to do the same thing. Give me that 1.3333 repeating. So those are all equivalent fractions. They all make the same ratio. And so I can say yes, they are similar. Now, it's important that you do not just check to see if the angles are congruent, because this is a case where the angles are all congruent between both of these. These are two rectangles. Also, because the angles are all congruent, I don't really know what the corresponding sides are, so I have to try both possibilities. Either this side and this side, they are facing the same way. So then I would say 7 over 6, 6 over 5. Those are not equal fractions, and so that would be a no. But it could be that it's the other way around. That 7 from this side corresponds to the 5 here, and 6 from this side corresponds to the 6 here. I don't know which ones are supposed to be corresponding sides, so I have to check both possibilities. But neither one gives me congruent fractions, so no, these rectangles are not similar. Even though all the corresponding angles are congruent, the sides don't make equal ratios. When you're finding the scale factor, all you're doing is making ratios of corresponding sides between two similar figures. So we know these triangles are similar because they tell us. That's the similarity statement there. And so if we're doing ABC to XYZ, we're going to do 6 to 3. And if we're doing XYZ to ABC, we turn that around. Scale factors don't have units. So in this particular problem, we do have to have the same units in order for those units to cancel out. And also, we see that they're asking for the scale factor of the model compared to the real. SUV. Now, it doesn't matter if I change feet to inches or inches to feet. It's easier to change feet to inches because you just multiply by 12. So that's what I'm going to do. I'm going to keep it in inches. So I have my 22 inches for my model. And then I'm going to have my 14 2/3 foot, which I need to change to inches. So the first thing I need to do for that is make that an improper fraction. So I'm going to do 14 times 3 divided by, or plus 2, which is 44. So that's 44 thirds. Then I'm going to multiply that by 12 for inches. So that gives me 4. So I get 176 when I multiply 44 times 4 inches. So that goes down here. Now we want to keep this as a fraction. So in your calculator, once you've got that, do this alpha y equals 22 over 176. Because both of those are whole number, it will reduce this fraction for us to give us this 1/8, which is our scale factor there. Okay, notice no units on that. It's 1 to 8 is the model to the real. And then to solve for missing sides, you have to first write the similarity statement. Well, again, we can use the congruent angles to write our similarity statement. So if I start with R here, I've got R, and I'm going to just go around this way, just so I'm doing it in alphabetical order. So I have R, S, T, U, V is similar to A, B, C, D, E. Now, you don't have to write it in that order. As long as you're going around, make sure you're not skipping across. Okay, I have to go either around this way or around this way, but I can start with any letter I want. But I do want to make sure corresponding parts are in the same place. So R and A, S and B, and so on. Okay, so there's my similarity statement. To find X, I need to find where I have an X, which is this side right here. X corresponds, the side with X, RV, corresponds with AE, according to my similarity statement. So I can make that ratio. And then what I want to do is I want to find a pair of corresponding sides where I know both of them. And so that's going to be this 18 to 4. That's our scale factor. And we can reduce that. We can make that 9 to 2, or we can keep it as 18 and 4. It doesn't matter if you write corresponding sides here or if you write the scale factor here because they're equal. The scale factor would give you smaller numbers to multiply, but it really doesn't matter. At this point, we're going to cross multiply. To get 4x equals 54 and x equals 13.5. Same thing for y. We're going to take the part that has y in it and make a ratio with its corresponding side. But once again, I'm going to set it equal to the ratio that I know for both sides, where I know both of them. And then I'm going to solve that one. So I get 4y plus 8 equals 90. 4y equals 82. So y is 20.5. And then UT, we're just plugging Y in there. So UT is going to equal 22.5. All right, so that's how you set up proportions to solve for missing sides in similar triangles. You make ratios out of the corresponding sides. One ratio should have the variable you're trying to solve for. The other ratio should be two corresponding sides where you know both of their measurements. All right, and finally we have this problem where it asks us to find the lengths of each of those, and we know the scale factor is 2 to 3. So if I were to draw a picture of this, I have ABC. I have 6, 8, and 10. And then I have XYZ, and I don't know what those are, but I know the scale factor. So if I want to find side XY, I know that AB, according to the similarity statement, AB corresponds with XY. So I have 6 over XY, and then we have 2 to 3, where ABC goes with the 2, and XYZ goes with the 3. So 2 to 3. I can cross multiply those. And get XY equals 9. I can do that for each side. So I can do that for YZ. YZ is going to go with this 8 because it goes with BC according to the similarity statement. So YZ is 12. And finally, for XZ, that goes with AC. And so 2 times XZ equals 30. So XZ equals 15. So that's how we would get those 3 sides. Now, in your perimeter activity, you should have found that the perimeter ratio is equal to the scale factor. It's also equal to the ratio of sides. All of those are equal ratios, which means you can make a proportion out of any 2 of those. So back here, if I wanted to know what the perimeter was, instead of finding each one of those and adding them together to find the perimeter, all I would have to do is take that scale factor and set it equal to the 2 perimeters. So I know this perimeter, if I add all those together, is 24. And then I could find the perimeter of XYZ by setting up that proportion. And so I know that the perimeter is going to be 36 without having to add these 3 together. But if I add them together, I can see that that perimeter is 36. So you want your proportion to be the scale factor and then a ratio of perimeters, just like we were doing scale factor with ratios of sides. Those are all equal ratios. So on this one, since I don't know the scale factor between them, I have to find the scale factor by doing a ratio of known sides. So since these sides are both 4, then I can see right here that I have a 4 to 3 ratio, because over in my similarity statement, AEN, because this is also 3 over here, goes with PT. So I have a 4 to 3 ratio. My scale factor is 4 to 3.